video, we're going to go over how to use a calculator to be able to evaluate trig functions. We're also going to go through the fundamental trigonometric identities. So let's start by using our calculator. So we're going to begin by finding the sine of 76.4 degrees in degree mode. Now this is specific because we have degree or radian mode. So what we want to do is we want to go to mode on our calculator and make sure we're in degree mode. So notice here that we're in radians. We're going to arrow over, hit enter on top of degree, and now we're in degree mode. So we're going to enter in 46.4, the sine of 76.4, and hit enter. And here we're going to find that we have a value of 0.97196100006. We'll go ahead and we'll estimate that and have 0.97196. Now, for our next one, we're going to find the cotangent at 1.5, but this time we're going to be in radians. So we need to go back to mode and select radian. And now we can go ahead and get out of that. And now we want to do the cotangent, but notice we only have a sine, a cosine, and a tangent button. Cotangent is not tangent to the -1. That is the inverse of tangent. So how is that going to plug that in our calculator? Well, what we're going to do is we're going to hit alpha, y equals, enter, option 1, and go down to tangent. We're going to put 1.5. So let's do that. So again, we're going to go alpha, y equals, we're going to hit enter, then we're going to hit 1 over the tangent of 1.5. Oops, too many tangents there. Let's try that again. There we go. Of 1.5. There we go. And now we hit enter. And here we're going to get a value of 0.07091484443, which will round to 0.07091. So what we just did there with that cotangent, 1 over tangent of 1.5, that actually happens to be one of our fundamental trigonometric identities. Specifically, it's in the reciprocal identities. So if we look at our 6 trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, sine is actually 1 over the cosecant of theta. They are reciprocals, which also means that cosecant, it means that cosecant is actually the reciprocal of sine, so we can write 1 over the sine of theta. For cosine, we put 1 over secant of theta. For secant, we put 1 over cosine theta. For tangent, we put 1 over cotangent theta. And cotangent, we put 1 over tangent theta, like what we just did. Let's go over some other fundamental trigonometric identities. So another identity that we have is quotient identities. So the quotient identities are that if we have the tangent of theta, that can also be written as the sine of theta over the cosine of theta. And using some multiplication, that tells us also that the tangent of theta times the cosine of theta equals the sine of theta. Another quotient identity is for our cotangent of theta, which is the cotangent of theta equals the cosine of theta over sine of theta. Then using our quotient identity, we can manipulate that to say that the sine of theta times the cosine of tangent, so the cotangent of theta equals the cosine of theta. Another type of identity that we have is our Pythagorean identities. So for Pythagorean identities, we have sine squared of theta plus the cosine squared of theta equals 1. Now, we can manipulate that as well. Like if we take that and we subtract cosine squared of theta from both sides, that tells us that the sine squared of theta equals 1 minus the cosine squared of theta. We could also do the same thing and subtract the sine squared of theta from each side and have the cosine squared of theta equals 1 minus the sine squared of theta as well. Now, other Pythagorean identities specifically are 1 plus the tangent squared of theta equals the secant squared of theta. And the same manipulations can occur here that we just did with our sine squared of theta and cosine squared of theta. And another Pythagorean identity is 1 plus the cotangent squared of theta equals the cosecant squared of theta. And again, that can be manipulated as well, just as we manipulated our sine squared theta plus cosine squared theta equals 1. So now that we know what our trig identities are, our fundamental trig identities, let's do some examples of applying these trig identities. So in this first example, we're going to have let theta be an acute angle such that the cosine of theta equals 0.8, and find the values of sine of theta and tangent of theta using trigonometric identities. Now we know that we have the cosine, we're going to use trigonometric identities, and the cosine of theta equals 0.8. So what do we know? Well, using Pythagorean identities, we know that the sine squared of theta plus the cosine squared of theta equals 1. And we know what the cosine of theta is. So we can plug that in to our cosine of theta and square it, allowing us to then have that the sine squared of theta equals 0.64 equals 1. So we'll subtract the 0.64 from both sides, and that's going to give us that the sine squared of theta equals 0.36. But didn't want the sine of theta, or didn't want the sine squared of theta, and wanted the sine of theta. So we can square root both sides. And that's going to tell us that the sine of theta is 0.6. So now that we found that, now we only need to find our tangent of theta. So our tangent of theta is sine of theta over cosine of theta. Now this was from one of our quotient properties, right? If we come up here to our quotient property, we see that the tangent of theta equals the sine of theta divided by the cosine of theta. Okay, so we have our cosine of theta there equals sine of theta over cosine of theta, and we know what the cosine of theta is now. We know that that value is 0.6, and we were given the cosine of theta was 0.8. So we can simply plug that into the calculator and get that the tangent of theta is 0.75. So now we have found our tangent of theta and our sine of theta, and we're finished. And we did it using our fundamental trig identities. Let's do one more example where we're going to be applying trig identities. All right, so in this example, we're going to let theta be an acute angle such that the tangent of theta equals 1/3. And we're going to find the values of the cotangent of theta and the secant of theta using trigonometric identities. So what do we know? Well, we know that the tangent of theta is 1/3. We also know that the tangent of theta is sine of theta divided by the cosine of theta. So if we write down our tangent of theta equals 1/3, that tells us that the 1 is our sine of theta and our 3 is our cosine of theta. Now we know that the cotangent of theta is the cosine of theta divided by the sine of theta. So to find our cotangent of theta, we simply need to put our 3 over our 1, or take the reciprocal of our tangent, which gives us that our cotangent of theta is 3. Now, in order to find our secant of theta, we know is 1 over cosine. And we have what cosine is. We were told that cosine is 3. So we can plug that in, and now we have our our secant of theta as well. So using our fundamental trig identities allows us to find other identities values as well.